Hello, this is the OSSera Service Manager demo. We'll be going through the SIP tools. SIP is an acronym that comes from the Telecom Management Forum Enhanced Telecom Operations Map. It outlines the SIP as strategy, infrastructure, product. These are the administrative and planning specification processes that are used to define your service models and then store them in a unified data model or service catalog. Our unified data model then can be deployed into a service operations environment. We're going to walk through some bottom-up and top-down service modeling, starting off with the importing of data. The administrator can populate the service manager system through various data files, whether it's Microsoft Excel, Visio, or other formats. The data populates the node information that is the foundation of the service model. So the resource nodes can come from your planning system, other service catalog systems, NetExpert, fault management system, as well as correlator information can be populated into the system. And this really alleviates you having to enter it manually. You can extract it from another system that you have. Once the data is loaded or imported into the service manager system, we've started off with the nodes, the lowest level. So here we're looking at SM network node. We just expanded SM network node and we can see all of the various nodes, the SMSCs that are loaded, and the TMS, the VRUs, and so on and so forth. We've selected a VRU and now we're looking at the properties. Here we're looking at the features tied to that VRU, and you can quickly go in and modify some of these properties as well. If we select a functional node function, and let's say we want to add an element, you can actually look at the element and modify the value if you choose to at this point. So this is a tree view that we've added that allows you to quickly go in and modify some of the managed objects, the managed object properties, and the attributes tied to those managed objects that were preloaded. Okay, so now that we've loaded the nodes, we have node groups, and node groups were defined by this particular customer that we're working with, and they also loaded these node groups, imported them. In this case, we can import them from a file or from Microsoft Excel, for instance. The information is then loaded and mapped to the actual nodes. So in our example, we're going to just show it here. We're going to select SM node group, and you can actually see the nodes tied to the SM node group. On top of that, we want to be able to see the diagrams, and the diagrams are either loaded from Visio or they can be developed in the service manager product. Once we've loaded the node groups, here we're going to define the node group using a diagram, and as you can see, we have quite a palette of different tools. We can drag the tools on, lines, basic shapes, labels, and we define the node groups that are made up of nodes. Once this is done, then the next person steps in, and that person is usually the service planner that takes the node groups and defines the actual services that leverage those node groups. Okay, let's take a look at how we model a service, and this is the role of a service planner. This is the exciting part because we actually start to see how the service actually works. To do this, we have various different diagram types. We showed you the node group diagram, but let's look at something more interesting. There's something called a sequence diagram in industry terminology. In this particular example, we call it a service flow diagram. And the service flow allows us to look at the sequence of interactions between the different node groups. This is very, very special because now we can take each node group end to end, in this case a mobile service, the NFW, the NSG, and show the individual steps and commands, number 1, number 2, number 3, number 4, between all of them. The node group itself is shown at the top, and from there we can drill down on a particular node group to show the node group diagrams as well as the individual nodes that we had created in the previous step from importing the data from Microsoft Excel. So in this example, I'm drilling down further and I can actually see the individual nodes within the node group. So we can traverse this. This is a living sequence diagram. It's not just a Visio diagram. It's a living sequence diagram that sits on top of node groups, that sits on top of a unified data model that's all cohesive and can be deployed into a runtime system so that your events and alerts can be propagated across this service sequence diagram. Even more special is we can take this sequence diagram and create a service topology. And it's like a network topology, but it's showing logical steps. So the individual interactions of 1, 2, 3, 4, and so on are shown here for this roam agent and prepaid number to work. It shows the end-to-end steps to make that service operate properly. So the service planner really has two very special ways to look at their services that they're modeling. They can look at it from a sequence diagram perspective, showing the interactions, as well as a service topology view, which shows the interactions end to end in this view. As we look at today's world, these services are becoming more complex. Whether they're cloud-based services, whether they're mobile-based services, whether they're broadband services or corporate services, they're traversing many node groups. They have not just bottom-up, top-down, but interactions that must be modeled. Now we're going to look at the service impact diagrams. Service impact diagrams represent the propagation of the node groups up to the services and at the very top, the customer-facing services. In this tree diagram, the service planner builds the hierarchy, and we're going to drill down on the resource-facing service, which shows the individual node groups. This type of tree diagram is then stored in our unified data model and deployed into operations to help with service impact analysis. So we've seen node group diagrams, service flow diagrams, service topology, and finally we've seen service impact diagrams. Finally, we're going to look at the correlation logic or correlators. Correlators are policies and or rules that are executed during runtime. So when you're in operations and you're receiving alerts in a multi-threaded environment, you want to collect all that information, execute it as quickly as possible. The correlator rule shown here has filters. The MO stands for manage object filter. The alarm filters below it, and the condition is executed. In this MO filter, we support regular expressions. So this object name is searched for, and the MO filter is actually optional. The alarm filter below it searches for this particular DN node down alarm, which is a critical severity, and then the conditional counting is applied against this match. So if the alarm comes in and matches, the MO name matches, then the counter will go off, will generate a severity of major or critical depending on the count that is received. So once the correlators are defined, they are associated with a node on your service impact diagram, and in this case we can see there's various rules or correlators that were created. Forwarding alarm correlator is the class here, and we can selected list and associate it to a node on our service impact diagram. So this allows us to now not only model our service impact, our service topology, our service sequence and flow, and our node, but also take these various correlators, threshold node, threshold alarm, service manager, correlation rules, and policies, and apply them to the actual diagrams in our service topology.